Okay, so now we have talked about various things like clustering. We have given a part 1 in subsection. I've given you unsupervised learning applications, and then we have talked about various applications of unsupervised learning, and then I've just given you an overview of clustering in this first subsection. In the next subsection, I've given you the intuition behind clustering. I've given a formal definition of a clustering. We have talked about intercluster, intracluster. We had talked about the evaluation matrix like Dunn index, Davies-Baldwin index, and I've made you understand each and every equations, and I've also helped you to understand what are the types of clustering which are available, like partitional based, hierarchical clustering, then we have a center based, world separated, density based, continuity based. Okay, so we have this kind of clustering which are already available. Now we will talk about a partitional and center based clustering, which is K-means algorithm. As this example was taken from Andrew Ng course of machine learning, but he has but it's too much 37 years old, but I have made it very updated for 2020. Just this example is from Andrew Ng. Okay, so I've also included K-means plus algorithm, what the K-means plus algorithm does, and some of the variations of K-means. And then also I have talked about in detail what are the limitations of K-means clustering, how we initialize the centroids, what are the time complexity of K-means clustering. Okay, so then we have talked about the full K-means clustering algorithm, how we evaluate our K-means clustering algorithm. Okay, with the Euclidean distance. So that's what we are going to talk about. Just be sure to just sit somewhere and see and take a copy and pen to understand. Okay, but before that, what we are going to study is K-means clustering algorithm. Sometimes the synonym of K-means clustering is Lloyd's algorithm. It's sometimes called Lloyd's. It's sometimes called Lloyd's algorithm. Okay, so it may be some people pronounce it as a Lloyd's algorithm or a K-means clustering algorithm. Okay, but I like to pronounce with K-means. Okay, so just as an example, we have this data set. We have this data set over here. Now what we do in clustering, we initialize centroid, which is K. Okay, we initialize centroid, which is denoted by K. So here it is a hyperparameter. So what we are going to do, we are going to initialize K as which is two centroids, and centroids is just the initial. You will get to know with the visualization. So what you do, you initialize with 2 points onto this. So here you initialize 2 points like this. The first point is over here, the first point is over here, and the second point is over here, and these are called the centroids. You will get to know why we call it as a centroids, but these are called the centroids. Okay, these are called the centroids, and here in this example K is equals to 2 because we have taken K equals to 2 because as we have 2 centroids and we randomly initialize these centroids. Okay, so we'll see the initialization just after some PPTs, just some slides. Okay, so you initialize your model now, and now this is the first iteration. Now in first you initialize, then what you do, you do the assignment step. What do I mean by assignment step? First you initialize, then what you do, you do assignment step like this. You assign all the particular value, means red to red color and blue to blue color. You can see over here that we have done red to all the red color which are closest to this centroid, and this blue we have covered that is all the centroids which are closest to that blue. Okay, now what we will do, we will take out the average of these points. We will take out the average of these whole blue points, and then we will take out the average of this red points, and then what we will do, we will average it like this. We will average it. Now after averaging, we will make that centroid to at average, and then what we will do, again we take out the we do the assignment step like this. We just update our values which are so closest to this centroid. Now you can see that the blue becomes like this. Now then what we will do, we will again move the centroid. Again we will take out the average and move the centroid like this. We will move the centroid, and then we will make this red means so those are closest to blue, and these are to red. Okay, then again you do like this, as a taking out the average and making the color as blue and red. Okay, now you can see that what you have done, you have a very good cluster, means you have initialized here, and then you taken out the average, then you move to that centroid, and again you update the cluster, and then again you move that like that. Okay, so we have done like that, and I have just shown you a very good visualizations of this K-means. So let's see again in a little bit more fundamental way. Okay, so here is our data, and then you can see the data looks like this. So here what we had done, we had simply initialized two centroids like this, and then what we have done, we had just make the points which are closer to that blue and red to that red. Okay, now you can see over here. Then what we have done, we had taken out the average, and then we moved our centroid to that average. Okay, and how we take out, you all know how do we take out the average. You just take out the number of observations and then divide or the sum over the observation divided by the frequency over the observation. You just do that, and then you update it, and then you again make the whole assignment step. And then what you do, then you again take out the average. Now you again update the points, you can see like this, and then you again take the average, you again make the points as like this. Okay, and after until and unless your centroids are not changing, you keep doing this. Okay, so here is informal algorithm. And you can see over here, after 7th iteration, it is not changing, so we converged. Our algorithm is converged. Okay, so this is how whole K-means clustering algorithm works in visualization. So let's see the algorithm in detail. Okay, so what you do, first of all, here's an algorithm I'm writing. Just bear with me, but just bear with my handwriting. So I'm just writing an algorithm. So here is my algorithm with the red's written with a red color. So let me write, here is your algorithm. Okay, so you do for K for centroids. Okay, so you have to choose K. Okay, you have to choose K, which is K where is a hyperparameter. Okay, then you repeat these two process. The first process is cluster assignment. You assign all the clusters, you assign all the cluster, and then update, take out the average, and then take out that cluster assignment, you assign the clusters, and then you take out the average, and then you make that point. So then you do the updation of a cluster. Okay, then you recompute the centroid. Okay, then you recompute the centroid. Okay, then how you recompute the centroid? The centroid, it simply means you make you take out the average, and then you assign that cluster. Okay, that cluster to the nearest data point. Okay, again you take out the average until your centroid are not changing. Your centroids are not changing. Okay, where it means that your algorithm is converged. Now you don't need. Okay, so you repeat these two process, like cluster assignment means assign the cluster with blue or red, and then you update your centroid and by taking out the average, and then again doing this, taking out the average, again doing this like that. Okay, so this is the basic algorithm of K-means clustering algorithm, and I hope that you understood about K-means. So let's understand a little bit more way is a little bit more further into just a recapitulation of K-means. K-means clustering is an algorithm also called the Lloyd's algorithm. Then what we do, so let's go back to our visualizations. Okay, so here is our data, and what we do is we randomly initialize two centroids. Okay, not every case, just have taken, it is a hyperparameter, we have just taken 2 for this case. Okay, then what you do, then you do the second step, which is which first you do the cluster assignment. You do assign all the cluster with the closest with the same points into the cluster. Then what you do, then you do the recompute the centroid by taking out the average and moving the centroid. Okay, then you do the cluster assignment, then you assign the cluster like this, then you again move the centroid. Okay, recompute the centroid, then you assign the like that, and then you take out the average, and again you do the same. You take out the average and then move your centroid. Okay, now in the next iteration, it is not changing. Now your K-means clustering is converged. Now you are done. Okay, so here's a good algorithm. You will be able to see on the internet the same thing. Like first you choose K, how many number of K clusters, then you assign the clusters, recompute, and then until and unless your centroids are not changing. Okay, so this is whole about K-means clustering algorithm, and I really hope that you understood K-means clustering algorithm. So now let's see some evaluation techniques of K-means clustering algorithm. Okay, evaluation technique, how do we evaluate our K-means clustering algorithm? So for an example, here is my example. So for an example, we are given no, not in for an example, is just I'm giving you the optimization objective. So you are given X d-dimensional space as well as K and the clusters which are this in set, I think the dictionary, which is in there's C1, C2, all the way down to the CK. Okay, we have K clusters. Okay, then what you do, you want your to optimize C, you want to minimize this cost function. Now what you do, you take out I equals to 1 all the way around to the K, where X be the member of Ci, means the cluster. Now you take out the distance of X and C. Okay, you want to minimize this cluster. Okay, so just it will make sense, don't worry. Here we have Ci, which is equals to the centroid. So let's see what do I mean with this distance between X and C. So what we are told, that what we are told, like we are told that we have that we are given X d-dimensional space, and we have clusters which is C1, C2 all the way around to the CK, where we have K clusters. Now what we have, we have this equation I equals to 1 all the way down to the K. We are going to till every clusters where each X is the member of cluster, means this data point is the member of this cluster. Okay, now you take out the distance between this data point and this cluster, this cluster. Okay, and this should be minimized. Your distance should be minimal. Your distance should be minimal as compared to this. Your distance should be minimal. So that's what it is telling over here. Okay, so I hope that you understood with the help of a visualization. Okay, so Ci is the centroid. Okay, cluster centroid. Okay, so how do we take out the distance? For taking out the distance, we have something called as a Euclidean distance. Euclidean. For taking out the distance, we have something called there are a lot more distances which are already available. You can take a look at it online, but it's very used, Euclidean distance. So what is Euclidean distance? In Euclidean distance, we have D, we have 2 points P and Q. Okay, means we are doing for each and every point I equals to 1 all the way down to the N, means number of training example, Qi minus Pi squared. Okay, and it's taking out the square root of that. Okay, so this is the Euclidean distance that just measures the distance between 2 points like this, and you can see more about this onto the internet, how we derive this equation, what is this, who found it, etc, etc, etc. Okay, and sometimes this cost function of K-means clustering is called SSE, means sum square error, and you can also see it is just like the done index following the inter and intra cluster. Here we want to minimize our intra cluster over here. We want to minimize our intra cluster. Okay, so that's the basic definition. That's the whole story about K-means clustering algorithm, and I really hope that you understood K-means. And then we have talked about evaluation techniques for K-means, and that's it for K-means. And now we will talk about why it matters, means the basic definition of why it matters, which is the random initialization. As we have seen that we initialize our centroids, these centroids randomly. You can see that we have initialized randomly. So why it matters, how it can cause the problem. It can cause the problem. So here we had just chosen, you can see over here that we have in iteration number 1 we have 3 centroids. Iteration number 2 we take another average, compute, then we do the we simply what we have done, we assign the cluster with the same centroid, and then we recompute by taking out the average in the second iteration, then in the third iteration, then the fourth iteration, and the fifth iteration, and the sixth iteration. You can see over here that you can easily see that we have a good cluster over here. But you can see in here that you have just it can cause, how it can cause problem is in iteration number you have just randomly initialized. Now you can see whole story changed. You can see over here. Okay, so that's the big problem. So that's why we do, which is very not recommended to choose it randomly. So researchers discussed about it. Researchers had talked about it, how we can use it, how we can make something good. So researchers found that K-means plus, something called as K-means plus algorithm works best which I'm going to tell you. Okay, so K-means plus algorithm, what it does, it simply select multiple numbers. It simply select multiple numbers, as in random we are just taking any random, but it selects multiple numbers and select the smallest error. Okay, so that's what the K-means plus does. It selects multiple means it's just a multiple, a sample from the numbers, multiple numbers, and checks which number minimizes the SSE, which minimizes the intra-cluster distance. Okay, so that's the K-means plus, and it is usually used in everywhere. Okay, rather than randomly. Okay, so we have talked about why we choose importance, why we choose why we choose K-means plus over randomly, because maybe it can happen sometimes. Okay, if the luck is not with us, it can cause a big problem and further. Okay, so how we have to deal with this kind of situations. For dealing with these kind of situations, we have something called as K-means plus, which will help us to do, which just selects the multiple multipliers and select the numbers which has the smallest error. Okay, so let's see. You may think, hey Ayush, how do we select how many number of a centroid that we need? Okay, so that's also the best, that's also the big problem. So we have something called as elbow method. And what it does, we have elbow method like this. We have written the K clusters 1, 2, 3, 4, 5, 6. Okay, now if you have taken K equals to 1, your error is high. If you have taken K equals to 2, your error is going down like this, like an elbow. Okay, so here you can see the elbow turns around at 3. So you select this elbow, you select K equals to 3. Okay, so this is your loss, this is the number of a K, and this is your loss, which is decreasing, SSE. Okay, so that's why how we use elbow method. Either you can use grid search, CV, or randomized search to tune this parameter. I think that will not work because we don't have labels, but elbow method works best when you plot it. When you plot it and see what number of k you need. Okay, so that's it. That's the following, and let's revise so that we are on the same page. So what we do in K-means clustering algorithm, we choose number of a k using the elbow method. Not now, just I choose it randomly, and then we plot it, and then we choose the k. And then what I've done, then we repeat like cluster assignment, like we assign all the clusters with the same clusters. Then we compute the centroid by taking out the average. Okay, then you keep repeating this until and unless your centroids are not changing. And then the evaluation technique for your k-means or loss function for your k-means is you want to minimize your intra-cluster by just taking out the distance between distance between the points inside the cluster. Okay, and then that's called sum square error, and you take out the distance using the Euclidean distance that just take out the difference between 2 points by doing the summation over there. Okay, great. So how we choose the how we choose the centroids? Okay, the initializing those centroids. For initializing, you have seen over here that randomly initialize can cause a very big problem. So that's why we have something called as k-means plus, which will help us to select centroids using what it does. It does from multiple runs and checks where checks the numbers where the SSE is low. Okay, and how we select the number of a k? We select the number of a k by using elbow method, where the elbow is where elbow is turning around like as a hand. If you draw it like this, if I draw a hand over here, if you draw it like this. Okay, so here elbow is there, so your loss is decreasing with k equals to 1 is your loss is this. Okay, so you choose the elbow k equals to 3 and it works best. Okay, so we had talked about these things, and now it's time for ending up k-means clustering, the chapter of k-means clustering, which is just ending the topic with our favorite, what are some of the limitations of K-means clustering algorithm, and what is the first time complexity. So the time complexity of K-means clustering algorithm, the time complexity of K-means clustering algorithm, if you don't know if you don't know DSA, leave it. Okay, ignore this. The time complexity is order of n times k, and n is the input size, k is the number of clusters, I number of iterations, d the dimensions. Okay, this is what the time complexity of that. Okay, so it's because the time complexity depends upon your size. If you don't know about time complexity, I have something called as DSA mastery course. Soon putting videos onto that. So first 4 lectures are based on time complexity. You can watch that. Just go anywhere. I will just show you where you can go. Okay. Some of the limitations of K-means clustering algorithm. Some of the limitations of K-means clustering algorithm is it's very sensitive to outliers. Okay, so let's assume that you have this oops, why PowerPoint Control Z does not work. I don't know why. So here we draw an x and y plane, and here we have x, here we have y, and let's assume that we have made it. And here we have the outlier, here we have it is closer, so it will take that outlier in that cluster. So we don't want that, so it is very prone to outlier, means we have to detect the outlier, and it can be solved using density based even I just don't know what what's there. So it can be solved, outliers problems can be solved using a DB scan, which you have a problem set to solve. Okay, means you have to read the Wikipedia page and write Google Docs onto the DB scan what you understood. Okay, and then it's like different sizes, different distances, maybe they're causing the problem. Okay, but the main problem is outlier. Okay, K-means is, so I have given you the thing that DB scan hierarchical clustering works on these types of issues. Okay, so that's it for this K-means clustering algorithm, and where you can find the time complexity videos, and it's very recommend it's very helpful. if you subscribe this the New Era YouTube channel, which you can find, which you can easily find onto the YouTube just by writing New Era, where I have 502 subscribers as of now. Okay, so you can subscribe that and see the DSA Mastery course, where we have more than 23 videos already uploaded, long lectures, so you can learn about time complexity from there also. Okay, so that's it for this subsection. You now have a toolkit of various algorithms, various techniques, various things. Okay, so now let's meet at the next section, where we'll be talking about hierarchical clustering. I will give it a short so that it should make sense. Okay, so let's meet at the next subsection.